Thanks so much for joining us for today's webinar, Inside Look with Merv Adrian, Building a Modern AI Data Stack. We're lucky here to be joined by Merv Adrian, Principal at IT Market Strategy. Welcome, Merv.
Good morning.
And our own very own Colleen Tartow, PhD, and our Field CTO and Head of Strategy here at VAST. Welcome, Colleen.
Thanks. It's great to be here.
Well, before we get started, we pride ourselves on trying to be as interactive as possible with our webinars. And so, if you have any questions throughout the event, please see the bottom of your screen. You'll notice that there's a little Q&A box. Drop any and all questions that you have there. We will have a Q&A section at the end to answer your questions. And with that, I'll hand it over to Merv.
Well, good morning, and thank you for having me. I'm very impressed by being the guest who leads off here. That's great. One of the reasons that we decided to have this conversation was that I just finished a study, primary research study, with some colleagues at Bark Research. If you're not familiar with them, look them up. They're very interesting. And we partnered on this. The nice thing about that for me is they have a nice engine, lots of folks who can gather data and do a lot of the number crunching for us and present us with some of the data that we can then interpret. And we wanted to do this because I think one thing that happens with the introduction of hot new topics, especially in IT, is a phenomenon that cognitive folks call confirmation bias. We go out and we find the data that supports our hypothesis. And if you've ever watched a case study on stage at an event ever, that is probably the best possible example of confirmation bias. The dialogue goes like this: find us a customer who's doing this because we want to talk about it. That is classic confirmation bias. So we tried to go into this study with the idea that this is new. We don't know what's going on yet. And what we want to do is ask questions, not ones that confirm our biases, but ones that tell us what early adopters are actually doing. And so we talked in February of this year to 335 companies across a fairly sizable range of industries. Not surprisingly, if you can read this chart, a lot of them were information technology because, well, a lot of folks there are getting on this bandwagon very early. But around the world, not so much in Asia, but certainly the Americas and Europe, and all different sorts of sizes in this survey, to get a sense of just how far we've gotten here. And Boone, I don't know if you're going to advance the slides or I am, but we can go on to the next slide if you're ready. Thanks. So what we were after was some sense of the maturity of organizations that are going after this new AI stack, and how far along were they. And I've always believed one of the best places to start with is how well have you defined what you're trying to get done? How have you identified your stakeholders? What is the definition of success? How are you going to measure it? And what are the guardrails you're putting up on the application of this? So we asked people about a series of different standards that they need to apply to this. And you'll see them down the left-hand side. And what we asked them to rank themselves was, well, we're not even talking about this yet, or we are out there consulting our stakeholders and thinking about it. This is right to left, by the way. And then, okay, well, we've got that done. We are now drafting our policy. And then the top two categories, which we combined into the orange ones you see here, were we have now, in fact, formalized our standard, or we are in a revision based on the formalization process, throwing up a few interesting points. It was encouraging to see that most organizations have made significant progress here in defining things like security standards or data access policies. Those are fairly familiar, so we kind of expected it. Not quite so many were on AI program standards yet. It's new enough. And perhaps the result that concerned me the most was what came in lowest. And this always seems to happen with early technologies. We get out over our skis a little bit. We get to work before we've decided exactly how we're going to manage this project. And I think, Colleen, I think we'll talk about this in a little bit more detail, but this particular wave of technology is going to be bringing in things that are making decisions for us. It is, in terms of its ambition, likely to create much more exposure than many of the other waves of technology that we've had before. And it's really important to have a good sense of whether or not we've thought through what we need to make this really, really crisp and to conform to what our requirements are and what our company needs are. You can click to the next one, if you would, please. So what we found was those rankings of maturity exposed that about 20% of the respondents actually replied in the top two categories of readiness. And we decided that these folks are different from everybody else. We're still pretty early, February 2024. You know, we all started talking about ChatGPT about, what, 6 months before that? ChatGPT,
Yeah.
excuse me. I always flip those letters. So this is a good look at the early adopters. And we decided to call these folks the high readiness ones because they've gotten farther in their planning. And as we asked the rest of the questions in this study, we used them as a filter and said, how do they compare to everybody else? They've, after all, got the arrows in their back already. They've already learned a few things. And so we decided to see what they were learning. And there's a click here, Boone, that won't advance it. There you go. And this is actually a little inside joke, because if you look carefully at what it says there, high readiness, it's not spelled correctly. That label was generated by an AI program. This was a graphic assistant, and we asked it to put a high readiness box on the slide, and it misspelled it. We told it 3 times that it was spelling it wrong, and it still never corrected it right. So, kind of an early warning.
Well, it's funny because I was going to like Slack you later and be like, sorry, but you have a typo.
No, we left it in on purpose because it actually is, it's a good
Good.
story. It tells something very important. I get everybody's other favorite story is way back when Watson was new and they had Watson on Jeopardy. And it trounced everybody, except it didn't know that Toronto wasn't in the United States. It got a question about an airport location wrong. So, you know, you never know where these things have gaps. And of course, that's something we'll talk about a lot here. The problem of hallucinations with the stack is something everybody's figuring out how to manage. And we can click to the next one, Boone. This is my my last slide, I think. Oh, I forgot.
I get to talk and then you have, then
Yeah,
I have a question for you, but first we want to
go ahead. Go ahead.
figure out where people are. Yeah, so like in addition to all of your data, I'd love to see for the audience, like where are folks in their Gen AI project and product development? Like what are folks doing right now? Informal poll.
Yeah, it'll be interesting to see. And for those
Yeah.
of you who are still designing, hopefully you'll get some good ideas here. For those of you who are in production, a look back over your shoulder is always handy.
Yeah. And show us what you're
I don't know what your input is on how quickly people respond here and when you give us a heads up that we're going to close the poll. I see it on my screen.
Yep.
Interesting.
This
Okay.
is poll ended. So yeah, so nobody's designing, but we're all pretty split between testing and production. And then what does AI stand for?
I don't know if that's a comment.
Artificial intelligence, just to level set.
Apple Intelligence, I think, is the
Apple Intelligence, that's
new
right.
branding for AI. Yeah.
Right.
Good luck with that one, guys.
Amazing.
I think I had one more slide, and I'm not.
You do, it's sort of towards the end.
We pushed it farther. Okay, no problem.
Yeah, we did. Yeah. It's this one, right? But I want to talk through pipelines first, and
Sure,
then
go ahead.
I'm really excited to sort of level set. So
Absolutely.
my focus has largely been on large scale data management, time to value for data. And really what that's all about is streamlining the pipeline of data. And so on this lovely summer solstice day, I want to start by talking about the legacy data pipeline. So before we get to AI data pipelines, just to level set what this pipeline means. And so we've been doing this, you know, Merv and I and data as an industry, trying to get value out of data for a really long time. And for structured data, tabular data, this is something we've been doing for like, I don't know, 40 years at this point. Not me personally, not Merv personally, but for a while. And what that means is really, it's just as simple as, you know, producing data, ingesting it into a data and analytics environment, cleaning, filter, aggregating, joining it to make it more palatable for consumers, and then consuming it with something like a visualization tool, a reporting platform, or even machine learning. And hopefully this looks familiar to everyone. And 20 or 30 years ago, this looked very different. The source would be the mainframe, and you'd be using Teradata or some OLAP data warehouse and an ETL tool to handle the curation. And the consumption was largely like reporting platforms. And now we've got this modern data stack that folks talk about, which is like the same thing, but just cloud-based and SaaS, so that you don't need to deal with the infrastructure. And it's composable. I would say composable to a fault, because there's literally thousands of choices for the components of whatever modern data stack you're building, but the goal remains the same, right? To get value out of data. And so the focus here is on structured data. And it turns out that's actually a tiny fraction of the data that organizations are collecting. So you're ending up, you can see here, we've got, starting with maybe petabytes, maybe, of structured data. And so this stack has really been tailored to those volumes. So next slide, Boone. So in the AI world, things are different. One of the most critical differentiators in AI is that you're going to be focused on both structured and unstructured data. And that unstructured data can be audio, video, pictures, documents, literally anything. And the volume of this data is magnitudes greater than that of the structured data. So the data stack that you build, first of all, has to be able to scale to that petabyte and even exabyte level. But it's not just about the scaling, it's the pipeline itself that's different as well. And so you can see that here. This is like a real evolution of how we're treating data, because now you're really building the modeling into the pipeline as opposed to leaving it at the end for a consumption layer. And we'll talk about this, but you're going to be producing model feedback as well in the production realm. And so you'll still be ingesting the data into a platform, maybe putting the data into a lake, doing things like loading it, if it's structured, into a database for curation, because there is structured data here still. But that curation also needs to be cleaning and organizing unstructured data as well and getting it ready to be modeled. So I would assume, Merv, that when you're talking about things like AI readiness, that you're talking about things like being able to serve this kind of pipeline. Is that right?
Yeah, one of the interesting findings from the research, which we don't talk about in this, but there's 28 pages of charts, so we're not going to cover much of it. But one of the more interesting findings was that the early adopters that we were talking about a minute ago are mostly using structured data. Structured data is still at the top of the stack, and that's been the top of the stack in most surveys I've done for the last 20 years on all kinds of analytics and BI studies. But it reflects the fact that we start with the stuff we already have a pretty good handle on and tools we already are using. And this transition is, to your point, really going to involve people learning how to work with some of those other data types. That goes all the way down to the layer where they store it. How effectively have they stored it in a way that they can get to it quickly and connect it up to these pipelines they're going to build?
Yeah. And so ideally, you'd build something that can handle both unstructured and structured BI, AI, machine learning, all of that good stuff. But the thing I want to also call out here is that the AI data pipeline is different, not just because the scale is different, but also in sort of, I don't know, legacy or traditional pipelines, whatever you want to call them. You're rarely going back to that original data set, right? Like the people closest to the application or the data source are going to like rationalize it for everyone else. You're going to clean it, they're going to curate it, and then the people are just going to consume that end data, and we all move on. Right?
And that's why the letter T always appears, either ELT
Yeah.
or ETL, right? We're always talking about transforming the data.
Yeah.
The computes that we're going to do in this stack may have nothing to do with transformation at all. They have to do with reasoning and linking and relating that data to something else. Absolutely.
Yeah. And sometimes there's also governance in that too, right? Like you've got like safety and PII and regulatory reasons that like you don't want people looking at that original data. But you can see these arrows are showing that in the AI data pipeline, the opposite is true. You need to revisit your raw data, and you need to keep looking back at the raw data to make sure that your AI is doing the right thing as you're building out data sets. So I always like to give the example of a call center. I worked at a company where we were doing sentiment analysis on calls, and we were not doing AI at the time. I'm sure now that company is doing all sorts of fun AI on it. But, there's basically a lot of information in audio logs and transcripts that you can learn from, that you can learn from. And pretty much every call center company is probably going to have them transcribed and PII redacted and then analyzing for metrics like keywords, talk time, dwell time, etc. But like transcripts are horrible to understand sentiment, right? I am very sarcastic. So good luck understanding that I'm not angry, I'm cracking jokes, right? And so, maybe you're cracking jokes and you're angry, or maybe you're not speaking your native language, right? And so there's a lot of context that goes into that. And so the trick is to use AI to listen and model, but then re-listen and apply that human in the loop to provide that extra context and plot conversational strategies based on all of that to really lead to that good outcome and make sure you're getting the most out of your data. So there's a lot of feedback in the AI data pipeline is the point. And it's almost more of a cycle than a pipeline.
And many searches are entirely new.
Yeah.
We organize data to answer the questions that we know we're going to ask, or at least historically, that's what we've done.
Yeah.
Most of our structured data is designed around very specific application requirements.
Mhm.
When we start adding all this unstructured data that was just collected in case we might find a use for it later,
Yeah.
the preliminary motion is often search. Do we have anything that could speak to this? Does
Yeah.
anybody talk about this in any of these conversations? Do any of the pictures contain this kind of an image? Do
Yeah.
any of the scans show this kind of a tumor? Whatever it is we're looking for, we're often doing it for the first time in these kinds of applications, especially.
Yeah, absolutely. Boom, next slide, please. So, like I said, it's not just scale factors. There's a lot of differences between BI and AI. And I'm using those terms, loosely. They obviously are evolving all the time, but I take BI to mean mostly like structured, semi-structured data work, like the things that we can already do, right? Like that traditional analytics with maybe some machine learning and thrown in for good measure. But AI, we're talking about things like deep learning, predictive and prescriptive analytics, Gen AI, obviously, LLMs, things like that. But you can see here, I've listed out the considerations, and this is obviously not an exhaustive list, but it gives you an idea of the things you need to consider in each case. And so, for example, like if you look at real-time processing, like it's rare that people need BI with real-time processing. I mean, it happens, but real time is essential to an AI use case. I want my chatbot response now. I want ChatGPT to build this talk for me and Merv instantly. I don't want to have to wait around. So real time becomes really important. Oh, were we not going to tell everyone that we're bots? And it's also like the other thing that I always point out here is governance, right? Like governance and BI, fairly well understood, right? It's things like data lineage, data quality, SLAs, access control, regulatory compliance, things like that. And AI governance, whoo boy, that's
and really, really critical
yeah.
because we understood why we set up the guardrails we did for the prior
Yeah.
generation, even when we did, which we unfortunately don't do as often perhaps as we should, but where we have, we know why they're there and they're pretty clear. The ones that are going to be required for these black boxes we're going to drop in to make decisions for us are going to have a much higher requirement for transparency and auditability beyond lineage. How was that decision made? What were the variables and what was their weight? And what did we do to prevent bias in selection or bias in processing? That's going to be a big one.
Yeah,
Checkpointing
is going to be a huge thing too, because you're going to need to be able to reproduce things in certain cases. I also mentioned here that, I put a star next to regulated because like, who knows what the regulations are today and where they're going, but I also say feared. I always go back to like, 15 years ago, maybe when Target started sending out really targeted ads to people and sending flyers in the mail that were like, wow, how did they know I was looking for that? But people seem to have gotten over that and they've realized that it's also helpful. And Target's also mixed in things that you're not interested in to let people be less scared. But AI is a different beast. People think this is the beginning of Skynet, right? And so, yeah, maybe it is, maybe it's not. But I think governance, because of that, needs to really step up its game. And so, we need to figure that out.
There are two very different perspectives here. One is the people who are building the systems, And the other, of course, is the consumers. And from
Yeah.
the builder's perspective, one of the most frightening things is that literally every month, another national standard mandate is being issued.
Mhm.
The last 5 months have seen every month a
Yeah.
significant new geographically driven standard from a governmental body or a pan-governmental body being issued. And everybody who's putting systems out has to comply with those things. And it's going to be challenging, especially when they don't do things the same way.
Yeah. And I think that the difference is, rather than just describing what's happening, you're not just predicting what will happen, you're prescribing it. Right. And that's challenging. Right. And people are really challenged by that. It's kind of, they're going to take our jobs. And it's like, well, I honestly think that means data engineering is the most important job. But, I think,
I
you know,
disagree. It's prompt engineering, by the way, but yeah,
it's data engineering.
I'm just saying
Well,
that.
that's another webinar. We'll argue about that one. But AI is a different beast, and you got to think about this in a different way because it's going to affect people's lives. I mean, this is as important, this is as revolutionary a time and a technology as mobile as the industrial revolution in a lot of ways. So it's going to change things, and we have to really be aware of that and be able to really understand how we got to the answers we got to, which is a whole new ballgame. So,
Agreed.
yeah,
Nothing more pivotal that I've seen in 30 years of being an analyst,
yeah, yeah.
except
The cloud. I would say the cloud.
yeah.
Yeah. Um, okay. Well, we could probably spend another hour on this slide, so let's move on. Oh, you can click through these. So the last thing I want to touch on is data maturity. Um, in order to get value out of an AI program, I mean, a lot of boards and exec teams are telling organizations, we need to do AI. And they don't know what that means. It's like, well, what do you want to do with it? Right? Like, what is the end goal? But in reality, a lot of organizations, need to look at whether they've invested enough in the underlying data infrastructure, the data, people, processes, and technologies, so that they can understand if they have, precursor steps they need to do to get mature enough to do that AI work. And so here I've listed some of the things I think about when I think about data maturity. First and foremost, having a well-aligned data strategy that encompasses all data, not just structured data, and treats data like a product, a first-class driver of business. And there are a lot of things that come out of that for me, like federated and clearly articulated governance models, like we've talked about, but also domain-driven data architectures and ownership models, like having the people who are producing the data be involved in the life cycle of data, not just throwing over the fence to a data team. And significant data organizations that's really woven into the fabric of the company. And it's not just like a band of rebels over on the side doing data stuff. But that all said, I'm a data nerd at heart, so is Merv. So let's get back to the data. So my question for you, Merv,
Yeah.
is how does the data that your work has collected aligned with this evolution of data infrastructure and this concept of data maturity?
Yeah, I think the good news is that many of the trends implicit in this chart that we're looking at right now are not really new. They're in a new phase, perhaps, but we've been following along some of these paths for a while, and that's good. We have a handle on how to do a lot of them. I think the one that stands out the most as very different in an era when most organizations are, thank God, finally starting to take governance seriously. Um, we're taking a great leap ahead by talking about a federated governance model because the reality is governance tends to relate to the constituency and how marketing sees the world and how operations and how logistics and how the executive committee sees the world are and always have been different, and we've been able to get away with that. It is going to become difficult when the increasing implementation of governance creates knowledge graphs, excuse me, that are going to be essential to the interpretation of these things, and that those things are typically embedded in separate stacks, and they are going to have to be federated. Having knowledge graphs talking to knowledge graphs is not a conversation we've been having. We've been content to let the local governance of a system manage its local operation. And even in politics, that's hard. States' rights versus federal is a
Yeah.
perennial topic here in the United States, and it's true in AI, perhaps more than anywhere else, because where models start to talk to models, and that's going to be the norm. There won't be one model to rule them all. Um, the differences among those models in their semantic mapping of the space, which is typically going to be in a knowledge graph, is really going to be a critical potential roadblock if we don't get it right. We might get local hallucinations handled well, but then we will still have disagreements with the local hallucinations or the local corrected hallucinations on some other part of our landscape. That federated piece is frankly new, and I'm not actually seeing a great deal of discussion yet about how we're going to put these pieces together.
Yeah, I do think, yeah, that like you said, I think the governance needs to be everyone's job, right? Like everyone needs to be thinking about this, but there also needs to be some authority that is enforcing it and really saying for this organization, this is how we think about governance. And so it really is a federated model. Um, yeah. So I think the next slide is actually your last slide. It's data about this. So I'd love to hear more about like how you think maturity plays into all of this, but also I'd love to understand more about this
Well, in the
data.
spirit of discovery, we put together a list of technologies we knew people were going to have to be involved in. Many of these are familiar. You've already talked about some of them. And we, again, when we were done with the first pass of the data, went back and applied that filter and said, well, what about the high readiness folks? How did they differ? And are there significant changes? Not much. The orange bar is the high readiness people. So interestingly enough, compute hardware was not the number one topic in the general population, but by the time people had done a little bit of work, it actually wound up as the number one, significantly. 5%, on a survey of this size is a pretty reasonable, outside of the margin of error kind of result. So 83% compared to the second place topic, which was 78% of people are saying, you know what, we're really going to have to get this hardware environment right.
Yeah.
And anybody who's paying attention, who noticed that the most valuable company in the world is now NVIDIA, should understand this. And this is not your father's or your uncle's or your older brother's architecture anymore. We're talking about some completely new players here on this landscape. So you need to understand, how are things going to happen at the compute layer? How are things going to happen at the storage layer? Surprisingly enough, a lot of us thought that was a done deal, but VAST has proven us wrong. So there's more to talk about there. The good news is a lot of people are getting that they have to look at knowledge graphs. That made me very happy that it came in third here, tied with models and model selection. And people do understand it's not going to be one LLM. There's a whole section of the study that talks about specific models that are going to interact with the LLMs for domain, whether it's finance or healthcare. People are going to have multiple models talking to one another, which brings up that question of federated governance we were talking about a minute ago.
Well, and multiple multimodal models, right? So you have multiple kinds of data.
Yeah, multi-modal, modal.
Multimodal.
Yeah, we're gonna have to figure out how to get the three M's there,
Mhm.
right? We threw in a couple just to see whether people responded to them. Feature stores is what people not in the database world call the database, by the way. At least that's a DBMS guy's interpretation of it. But more cloud services, yes. Vector databases. Now, that's sorry for the background noise. My automated assistant wanted to tell me I had a message. Go away.
Oh, nice of her.
Alexa, off. Sorry. Vector databases are a very interesting topic. People are beginning to understand their significance in this stack. And I have to admit that the first time I started hearing about this market evolving, my immediate response was, well, that's a feature, that's not a market. I might still be right about that. I think every significant stack manufacturer in the IT space is incorporating vector databases into their stack. And the idea that somebody might go to a third party for one and then figure out how to integrate it with all the other pieces of technology they're building might just be, the straw that breaks the camel's back of complexity for some people. Time will tell, and I'm sure Pinecone would disagree with me. But at the same time, they may be doing a lot of OEM work and selling their technology into stacks, visibly or invisibly.
Mhm.
So, what we see here is very substantial gaps between sort of the general population and the high readiness folks, but they don't really change the stack very much, with the exception of I think probably the largest gap is right there at the top. Once you get into this, you begin to realize you really, really have to think about your compute hardware environment and whether it's appropriate, because
Mm.
some of these jobs are massive, some of them are of very brief duration, and some of them are continuous. All of them can be very expensive if you haven't configured properly. And older technology does not cope with some of the tasks implicit in some of these pipelines nearly as well as newer technology that's been designed for it. There's a reason why we keep hearing about new processors, new companies building processors, but new processors from existing companies, new storage methods, and advances at every layer of the stack, frankly, that are going to be required to make this work seamlessly.
Yeah. No, it's interesting because it's like, well, first of all, it's always nice to see data to back up what we've been, assuming is correct about our customers. So, um, yeah, and I mean, I think it's an interesting amalgamation of a lot of different aspects, right? You're thinking about compute, you're thinking about storage, so you're thinking about the physical stack. You're also thinking about the processes, the operations, and the management of the data. You're thinking about, do I do a data mesh? How can we federate governance? How can we think of data as a product? How can we deal with security and compliance? I mean, there's a lot of moving parts here, and there have always been a lot of moving parts. But to get to that level where you're actually able to do, to activate all of your data in conjunction with all of these moving parts, I think that's really interesting. And then also just keeping up with everything that's happening, right? Like, because who knows what'll be next, I always say.
There's always the interesting question when you ask a question like this one, and I could show you the language of the question itself, which is always sort of important. But
Yeah.
as we do these studies, one of the things we learn is how effectively the study was designed.
Mhm.
Many of these technologies are familiar, and it's not clear, candidly, whether people say, well, we're doing that, or whether they're now doing that in an AI project specifically. And it probably requires a question that's structured a little differently than we did first time out. I think when we go back for our next pass, which we're planning to do about 6 weeks from now, with some revised, refined, and added questions, we're going to try to get a little bit more precise about where these technologies are being applied,
Mhm.
which projects they're involved in, or whether they're just part of the landscape. Most people have compliance and regulatory management going on. Is it being specifically applied to an AI project or not? Might not have been precisely enough asked in this question. So,
Yeah,
good
it's
research
interesting.
asks questions, and some of it answers questions, and some of it raises more questions. And actually, that's my favorite kind. So,
Absolutely. That's where things get spicy. It is interesting though for compliance and regulatory management that for the less mature cohort, which is how I'm reading the blue versus orange, the blue is less
that's
mature.
correct. Yeah.
Um, Only 50% are saying they're there. It's a little scary, but but it's interesting that 76% are saying that they're more mature, and that they really are thinking about that. It's like I would argue everybody should be thinking about that all the time, but you know,
It was encouraging that on average, roughly 25% more of the high readiness people,
mhm,
were in there on these
yeah.
questions. That as they began to engage in their projects, they began to see the importance of these things. And
Mhm.
it was personally a little gratifying in terms of which things we chose to ask people about, that none of them fell way, way, way down in the 10 or 15% range. We
Yeah.
had the right set. Um, you don't usually use an open text box and say, type whatever you want here. You give people choices, and I think we
Yeah.
made a pretty good set of selections. There may be one or two we add or drop next time out, but yeah, people are
Very
moving
cool.
pretty fast once they start actually working on it.
Yeah. The data analyst in me wants to get my hands on that data.
We can have a conversation about that offline.
Okay. Cool. Thanks. Oh yeah, we already talked about that. So yeah, so want to take just a few minutes. I'm not going to do, incredibly long pitch or anything, but I do want to just talk about how VAST is thinking about a lot of this. Based on everything we've discussed thus far, I think a lot about what makes an AI data stack and how do we get from where we have been, which is that traditional BI work, to the AI world, because it's easy to say, oh, just spin up an entirely new environment. I think that's not realistic. And I think people want to, do something more iterative and then also make it extensible to whatever comes next. And so, these are some of the key factors, I think, in an AI data stack. And, obviously it needs to be scalable. We've discussed that. You need to be able to get to that sort of exabyte scale that we're talking about. Obviously, you need something that's going to be incredibly performant. And it's going to work with that latest storage and compute infrastructure and all of the innovations that we've seen. I mean, we've already talked about NVIDIA. I was at GTC this year. I don't know if you were, but it was bananas, the things that people are doing. But, there's this, people can't get enough compute. The stack you build needs to be composable too, so that it can work with existing solutions and adhere to any open standards that are already out there. If you have an existing legacy stack or traditional stack, you don't want to have two independent stacks. You want one data environment that works hopefully for everything. And adheres to open standards. Like if you're using Python, great, keep using Python. You don't have to build out a new language environment. You want to be able to ingest data from anywhere, whether from events or transaction, and be able to handle both structured and unstructured and multimodal data. And of course, the thing everybody really cares about, it needs to be cost efficient, because the higher your TCO for data, the lower your ROI, right? And so you need to be focusing on things like archive economics and not tiering data, because you need all of the data to do AI, but you want to make sure that, you're building an environment that allows you to get that archive economic stance. So we can go to the next slide, Boone. Coincidentally, obviously, this is what we would say we were building at VAST. The VAST data platform is really a data platform that we've optimized for storing and serving both structured and unstructured data at those exabyte scales. So we have several different features within our platform. For structured data, we have the VAST database, which is near and dear to my heart. I work very closely with that team, and I'll be talking about that more in just a moment. For all of the data, including unstructured data, we have the VAST data store, which is a multi-protocol, ultra fast, highly optimized storage tier based on an all-flash infrastructure, which gets you those archive economics we talked about without having to tier your data. And so all of that data in the data store is also going to be cataloged with the VAST data catalog. Now, this is not a Calibra style catalog with all of the bells and whistles of that, but it is a catalog so that you can focus on discoverability. Because, as we mentioned, even just knowing what data you have and are we able to answer that question with our data is a very important first step. And it plays into governance as well. So, knowing who's accessed what data, that's the kind of question you can answer with the VAST catalog. And coming in our next release, back, Boone, sorry, not done yet. I have more to say. We've got the VAST data engine, which is a way of using triggers and functions to act on data as it comes into that environment and as it is in that environment. So it's really an end-to-end solution for your data pipeline. That's really what we're focusing on. And obviously, the scales we're talking about, when we talk about exabyte scales, our customers are largely on-prem, right? But the cool thing about VAST is that it also works with IoT devices at the edge, obviously on-prem and the core, and then it also works on the cloud. We currently serve both GCP and AWS, but you can spin up VAST in AWS today if you like. But we also have Azure coming soon. So now we can go to the next slide. Thanks. So I don't have time to go into the super details of the entire VAST data platform, but obviously follow up with us if you'd like to hear more. But I do want to take a minute to just double click into the VAST database because it's really cool. And it'll give you an idea of the kinds of innovations that we've been developing in this platform and how we have this laser focus on accelerating the time to value for data. So the VAST database is especially awesome because it's both transactional and analytical. We are going to ingest data in rows into scale out SCM, and that makes it a fully ACID compliant OLTP database, if you're familiar with those. So it's going to have the functions and the ingest speeds of a transactional database. And you can click again, Boone. It then is going to push data down into hyperscale flash in a columnar format. And so that gives us OLAP functionality. So analytical queries can happen in a way that you'd expect from a data warehouse. So essentially what you're getting is all of the functionality of a data warehouse and a transactional database at the scale of a data lake. And because we're hyper efficient, we're able to do this with fewer compute resources, which again is going to lower that TCO for analytics and transactions and increase the ROI for data. And again, we're going to do this at exabyte scale. We can move to the next slide. I'm always going to give you data. So our write performance is incredibly fast. We're roughly 1,200 times faster than Trino and Parquet. We get a lot of our customers who are focusing on those open table formats and open file formats like Parquet and Iceberg. And essentially, we're going to be incredibly performant compared to those. So our read performance is, faster than Trino and Iceberg, Trino and Parquet and Iceberg for both ad hoc queries and selective queries. And then on top of that, you get all of these benefits that anyone using the VAST data platform will use. We have data reduction. On average, we get 3 to 4x data reduction. We also, because we've got both the transactional support and the analytical support, things like table updates and change data capture that you would typically have to worry about, and maintenance tasks like vacuuming and partition management, you don't have to do with the VAST database, which is really cool. So next slide. So getting back to like the ideal platform, I would say we're checking the boxes on all of these, which is very cool because in the end, what we're building is this cost-efficient, performant, and scalable platform for BI, for your structured data, and for AI, which is both structured and unstructured data, and then hopefully beyond whatever comes next. So comments, Merv?
Yeah, my primary comment is that I think, where you guys are coming from, where you have been coming from, really, really large scale on-premises data deployments and helping your customers make this transition into this new stack. And I think you've ticked, to use your expression from earlier, you've ticked the right boxes. You're recognizing that there will be other components to the infrastructure, and you're building integration points into your architecture and recognizing that you'll have to interoperate with those other pieces. I think that's a really encouraging way to go after the market. It's not unreasonable to compare your performance to the performance of stuff people have stuffed into S3 boxes, but they're going to do it anyway. So you'll have to be able to live with it. So this whole notion of building a fabric, having a federated governance model, putting all the pieces together so that they talk to one another, this is the path forward for almost everybody. And I think you've carefully chosen ways that are going to be non-disruptive and incremental for people who already have made some of their first steps. So yeah, I think VAST is one of the more interesting players on the landscape. That's why I'm here today.
We're glad to have you. I think that's actually it for slides. I don't know how much time we have, Boone, for Q&A, but I'd love to see if there's any questions out there.
We do have some time for some Q&A, and we've got a few questions that have already rolled in. I wanted to start us off with this one. Thank you, Ajit, for the comment here. We have kind of a question about federated governance, some of the issues with federated governance for larger repositories of data with larger corporations, specifically as it relates to those corporations using vertically integrated data stacks. Curious now, hand it off to Colleen and Merv, you can chime in as well. Any thoughts on this?
Yeah, I mean, I think the key to the federated governance is that you are accounting for both governance at the source, right? Like the things that you expect the data producers to handle. So things like entity standardization. I mean, governance is a huge field, right? There's things like entity standardization, there's access controls, there's things like that. And then you've also got regulatory compliance, like how are you marking PII? That's something that needs to be handled
Oh.
across domains, right? In all of the different business units. And so this needs to be something that you're playing with at all scales, right? And I think that's why, like we were saying earlier, this needs to be something that everyone has a hand in and everybody is aware of what good governance looks like and what is required, what is nice to have, and what is not required. And most of it's going to be the things, the focus, you're going to focus on the things that are required.
I thought the question was interesting because it used as examples some places where a large provider has its own stack of data that it might sell access to for marketing purposes, for example. We are certainly going to have to figure out what the boundaries of those data stacks look like. At some level, we will obviously have governance that talks about the regulatory requirements for privacy and bias and security and so on. But there's value add for those providers, obviously, in what they do know. We just need to understand how they know it and how well protected it is. In other environments, the broad scale sharing of data is one of the great promises of the future. I was just at an event in Washington, D.C., put on by InterSystems, as it happens, which was a very, very healthcare dominated event. And the degree to which providers, pharmaceuticals, hospitals, doctors are all sharing information, that promise, the electrical, health records that we've been talking about for decades is actually beginning to truly emerge. And there was nary a fax machine in sight in these conversations. Anybody who's had to fax their test results to their doctor, can relate to what I'm saying.
I know. I feel like that's a very US healthcare centric challenge, I hope. But yeah, no, I appreciate
But the
that.
notion that, we collected over here because a doctor dictated it into a machine, which got translated by some sort of AI program and transcribed, which then generated the appropriate test result request already coded for the payer information that's required to make it happen. This sounds like nirvana, but it's actually already beginning to happen, and that is an environment where federated governance is absolutely critical. The privacy of people's information is obviously paramount in an environment like that. So there has to be some agreement among these different folks who all have their own stack with their own governance rules. And it's a mammoth question, and for many industries, it'll be very many years before we get enough, I think, alignment, and maybe we never will among key players to interchange well. How much government has to do with all this? That's another open question.
Yeah. And I mean, I think there's definitely, it's a moving target, right? Like the things that you might say, you know what, our organization is good. We're already doing this. Like so much of governance is like compliance, right? And so it's like, are we already complying with this new regulation because we're already doing X, Y, and Z? Or is this a brand new effort? Or is this something that doesn't apply to us? Right.
Yeah, I think our discussion about federation is mostly federation within our own boundary. That is, my organization needs to federate its approaches to governance. Is actually going to be a first-class challenge for a lot of organizations. Once we go outside the walls, it gets even more complicated. The degree to which those regulatory bodies have created usable standards that don't disagree with one another is going to be one of the big questions of the next 5 years.
Yeah. Well, and it's interesting because so there's 4 pillars to data mesh, right? Like, so there's the domain-oriented architecture and ownership, there's data as a product, there's self-serve infrastructure, and there's federated governance. Guess which one people have the biggest struggle with? Like, guess which one people don't even touch half the time, right? Like, governance is a huge challenge, and I think it's evolving quickly. I think AI presents a whole slew of new challenges. And so it's going to be something that we have to focus on more and more.
If left untended, it will be the largest technical debt we have 5 years from now.
Absolutely. Yeah, absolutely.
Thank you again, Ajit, for the question. We probably have time for just one more question here. Looking at our questions, and if you didn't get your question answered, we will answer it after and send you the answer via email. I apologize if we didn't get to your question. But on the topic, Colleen, you mentioned data mesh. One of the questions we got was, how do data management strategies like data mesh and data fabric play into this?
I would love to hear Merv's answer before I answer.
How do they what?
How do
How do
data
they play
management
into it?
strategies like data mesh and data fabric play into this?
Oh, how do they play into this? Okay. So organizationally, for most of the entities that I talk to, the whole point of what's going on right now is bringing into discussion elements of data that we had stuck over there in the corner and weren't using. We can't use it on an ongoing basis effectively if it is not somehow materially and efficiently and manageably connected to the rest of the stuff. To use a technical term. So, building a mesh that allows you to get to that data in a timely, governed way is step one. You can't do anything until you do that, unless you start making unmanageable sets of copies that you're shooting all over the organization and storing in probably very bad ways, and at high expense, which is what a lot of organizations are doing today. Mesh is almost a necessary first step. You can't start building strip malls until you have an interstate highway system,
So we're building strip malls? That
Well,
tracks.
that might not have been my
We'll work
best.
on that analogy. No, I completely agree. And I think data mesh is interesting because I think it was born out of the struggle to succeed with structured data, right? Like something like, you probably have the number better than I do, but there's like numbers out there that say like 87% of data science projects fail. Right. And I don't think they're failing because people can't find the data necessarily, but I think they are failing for several reasons, one of which, there's lack of accountability around data. And I think that gets into sort of the culture around data, which I hope AI is going to serve to only strengthen that culture. And that accountability and the treating of data as a product is the key factor in anything here. And the way I think about data mesh is that it all falls out of the idea of data as a product, right? It may be the second pillar, but I think it's the heart of the data mesh. And I think it's really the thing that drives all of the other factors here. And then the other way I think about it is that we focused on discoverability and we focused on it for structured data. We have to do it, like you said, for unstructured data too, right? Like folks don't know what they have. They don't know what they don't know. And now that we have AI and people are being told to do AI, it's like, well, what does that mean? And like, do we even have the data to start answering these questions? And that's really the trick here. So.
And it brings us full circle back again to how well governed is that? Because just because we found it doesn't mean it's the right resource, right?
Yeah.
One of the first things I learned was Donald Knuth's, you can't test for you can't prove the absence of bugs, you can only prove their presence. Many of those data science projects that people thought were successful may actually have fundamental flaws they just haven't found yet. And that's going to be down to whether the data is actually right and actually describes what they think it does. So yeah, we have to get this right early because it's going to be so central to the operations of our enterprises that if we have flaws from the outset, it's going to be very hard to go back and fix it.
Yeah, and the quantities of data that we're talking about now to be discoverable are just, sorry, I always want to say vast, and then I'm like, oh, that's cheesy, but it is vast.
Yeah, it works. Yeah.
Yeah.
Perfect. Well, thank you so much for all of our audience here for joining us, and thank you, Colleen and Merv, for speaking this morning. If you have any questions or didn't get your question answered and would like to learn more, please fill out our post-event survey. We'll catalog whatever your next step would like to be with Fast, and anything you'd like to mention, or if you have any comments about the event, please drop those in there, and you'll get that survey popped up to you on your screen at the close of the event. But with that, I will close this out. Thank you everyone again for joining.
Thanks, everybody.
Thanks so much.